Hello folks, hope everybody's doing well. In a moment I will take you into an aircraft that I was flying and demonstrate to you a very important concept which in particular the Dash 8Q400 FMS does and has to be told what to do when we want to change our routing in the approach phase, in the descent phase. Okay, so for now we are routing from on our track here to, let's say, the initial approach fix, and then we go to the initial fix and the final approach fix. Okay, this is a standard proper full approach that can be programmed on any approach anywhere in the world that has an RNAV or an RNAV approach that transitions to ILS. All right, now the question comes that, okay, for example, let's say we are here where the black blob has been drawn, and traffic isn't a restriction and everything is calm, the day is good, it's not very busy. So we decide to go from where our present position, this one here, all the way to the final approach fix. So it's like a direct routing, and remember, such routing can only be done after authorization is given by the controllers. So we request to go from where we are all the way to the final approach fix. Now, what does this mean? First of all, we must know that the distance from where we are to the final approach fix will be shorter compared to where we are and following this whole routing. I think that's agreeable. If you have to straighten out this track here, it's going to be clearly very long compared to where we are all the way down to final approach fix. Yeah, so what happens and what do we need to do in such a situation? It's not that difficult, but it's a programming thing on the FMS, and I'll just take you into the aircraft once I've explained the theory part. Then we can go and see how it works in practice. So before we do that, before I show you the video from the actual aircraft flying where we had such a scenario, we must understand the concept. The FMS calculates a 3-degree glide path all the way to the runway, to the landing. So when you program a full approach, the FMS has worked its way backwards using the distances and the timings and everything it has in its algorithms to work out a 3-degree path all the way to where you are. And it's going to be updating that 3-degree path as you transition into the approach phase. The moment you disturb the FMS saying, okay, I'm here, forget about all this, let's just go from here to there. That's what you actually communicate with FMS. What it will say that, okay, you want me to go from here to there, I am very close to this distance if I have to use this route as compared to using that route. I hope you understand what I'm trying to say. The FMS will say, from here to there, I am very close to the final approach fix, and the distance is very short, and I'm very high. Okay, so this routing means that you are close, okay, to the final approach fix in this case, if we take that as an example, and we are also very high. So if I just go on the FMS and I just say, those of you are familiar with the universal versions of the Dash 8 Q400, that's the one which I keep saying that's the one I'm on currently. So you will realize that there is a function which is called DTO. DTO means direct to. So if you just do DTO to point C, immediately what it's going to do, the FMS say, oh wow, this is a surprise. So it's high and it has to capture a lower altitude compared to these ones. This is a CDFA profile, if you know what that means. It's called continuous descent final approach profile. Okay, so it's already calculated here initially when you program the FMS, but now you've disturbed it by just doing DTO there without telling it what to do. Okay, so if you do DTO to that this final approach fix, the aircraft, believe it or not, will dive. It will dive pretty badly. Actually, it's not a very comfortable feeling, and in extreme cases, we also look at structural issues and the like, depending on how high it is here and the difference between where it is and where it wants to be. Okay, you will see that these altitudes will be progressively decreasing, right, in the actual sense. So we will be coming like we are gliding downhill here. Okay, this is just a plan view. Okay, so we are gliding downhill. Now you want to go from here where it was initially going there and there and there, right from here to there straight. That is a very big vertical distance that the FMS has to accommodate, and to do that it will command the autopilot to dive, so we go there, and that's not what we want. We do not want the FMS to dive. So what do we do? This is where I'm going to show you on the video that I just made just today regarding how to program the FMS. It's a very simple procedure. The first thing you do, you should not be in VNAV. You are in VNAV, all this is LNAV VNAV, but you have to disengage VNAV. Okay, and to do that you disengage VNAV by pressing vertical speed. That will be the mode that you'll use. Okay, once you select vertical speed, the VNAV automatically will come with an amber message says this VNAV is disconnected. Fine. Why? Because now the FMS has been told I don't need VNAV anymore for now, I'm going vertical speed. Alright, so we're going to use vertical speed. So what we're going to do when we use vertical speed, what happens? We are maintaining the same vertical speed as we had with VNAV. Okay, so engaging the vertical speed will keep the aircraft on the same rate of descent while we reprogram the FMS on the new profile. I'm hoping that is making sense. Then we're going to go to a function called VNAV on the, we'll first of all do DTO to the fix. So we'll tell the aircraft let's go there, but for now it won't dive now because the vertical speed has been locked to what it was initially with VNAV, but now with vertical speed. So if VNAV was giving you a vertical speed of let's say 1300, at that moment when you press vertical speed, what happens? It's going to maintain 1300 unless you use a thumb wheel, which you shouldn't anyway, unless there's a need to, depending on also your calculation of the distance. Okay, then you press vertical speed, then you're going to do DTO to that particular point. So you're going to go to DTO on FMS, which will be shown, and then you select that point. So now the magenta, all this will disappear, and there will be a line from where you are all the way to the fix that you want to go to, in this case final approach fix. Okay, then you have to tell the aircraft, okay, now we are going there, let's recalculate the whole 3 degrees. That's when you're going to go to another function, VNAV, and then in VNAV you're going to go to VTO, vertical 2, and in vertical 2 you're going to select the fix that you've planned to go to. Once that's done, then you're going to go back, select fix, and then once that's done you're going to go back, and then you're going to press VNAV on the Fgcp. So this process, you'll note it down as you see the exercise in practice on the upcoming presentation after I've just narrated everything. I hope this is making sense. So you do not just go DTO with VNAV engage, otherwise you'll make things very uncomfortable and sometimes very dangerous as well if you have to dive to a lower level. So this FMS does not accommodate this sort of transitioning. Okay, so for you to change the vertical profile, you have to follow this procedure. So vertical speed comes first, then you do DTO to the particular point, then you go to VNAV on the FMS, VTO, select the fix. Once you press enter, then you go VNAV on the Fgcp, and then that's going to bring you the VNAV with a newly calculated vertical profile. Let's see now how that works in the real sense. Okay folks, at this point we are going to position OCPOL. We are doing a full ILS procedure. If let's say we are given a clearance to go direct to position IMVIV, my colleague Marcel is flying. He will show you what to do when we are given a clearance to position IMVIV. Remember that the FMS here is programmed to OCPOL. To go to IMVIV, the FMS has to be programmed to recalculate the whole vertical profile. So my friend, my colleague here, Marcin, who's with me right now, he will actually demonstrate how the vertical profile is done if we are given direct to the final approach fix of this approach. And he will do it as soon as we get the clearance. And then we will show you how the Fgcp is manipulated together with the FMS and the VNA VTO function, DTO function, and what annunciations to get on the PFD. So in a moment we should show you that. Okay, so we've been given the clearance to position IMVIV. So what Marcin is going to do now, the first thing you've got to do is to disengage the V path and use vertical speed. So Marcin is going to press vertical speed. There it is. Like that. Now what he's going to do, we are going to do DTO to the position IMVIV, which is number 7. Confirm, Marcin? We're going to do that. So next to IMVIV. And then the aircraft is LNAV, so we'll turn. As you can see, it's turning. And then we'll ask the aircraft to recalculate our vertical speed, descent profile to IMVIV. So we go to VNAV VTO to IMVIV, which is number 1. Confirm. Enter. And then the V path appears. And now Marcin is going to press the VNAV button. So VNAV. So press VNAV. And you can see V path has come. Now the aircraft is on its way down to IMVIV with no disturbance. If we had just gone direct to IMVIV without doing vertical speed, because of the distance, the aircraft will dive knowing it's high and it has to capture a lower altitude, so it will confuse the aircraft. So always remember, vertical speed, DTO to where you want to go, VNAV VTO to that particular point for the vertical profile calculation, and then you come here and do VNAV. I hope that makes sense. Marcin, introduce yourself. How are you?
Good, how are you?
Okay, always smiling. Well done. Good flying, my boy.
Thank you.
Enjoy. Okay. Okay, folks, I hope you understood the video, which backed up what I said in my graphics here. And also a point to note is that if you ever, by mistake, just do DTO to the final approach fix, for example, in your descent profile, you want to go to from where you are all the way to the end part of the approach. If you don't do the vertical speed, you will end up on the PFD with a pitch hold message. Okay, and that just tells you that the aircraft has been confused and wants to hold the pitch until you tell it exactly which mode to navigate in vertically. Alright, pitch hold is not a navigation mode. It is just there to tell you that I'm holding the pitch until you tell me which mode you want me to navigate in. Alright, so pitch hold is an annunciation which comes on the FMA on the PFD. And also for the aircraft to calculate this sort of profile from where you are quite high to where you want to go, which is a bit lower than the pre-calculated altitudes, it also depends on how close you are to the fix that you want to go to. There is a certain limit to which the FMS will be able to calculate the vertical profile, but if you reach a certain distance which is so close and you are so high, and if you try and do this maneuver, the FMS will just refuse. It will be like the target vertical speed is too low. and then it means the closer you come, it's just like this. If I draw it here, for example, let's say this is the fix that you want to come to, and let's say you are here, okay? So this is your distance from there. Now if you keep coming closer and closer to the fix, you can see you are getting higher and higher and higher. Okay, can you see this graphic here? It's just a very simple graphic. This is your fix that you want to descend to. From here the FMS will be able to calculate at a certain rate of descent. As you get a bit more closer, it will be able to calculate, but then there'll come a point where it will be like, now this is just ridiculous. Okay, the vertical speed will be so high, in maybe 3,000 feet per minute. I mean, you don't want to do that. You don't want to actually try and do such maneuvers in commercial flying. Okay, so it all also depends, this exercise which I've just shown you also depends on the actual distance you are. Until a certain distance the FMS will be able to calculate, but then itself will say, this is too much for me, I cannot do it. Okay, and obviously if you are on top of the fix, you want to go down. I mean, you're not a helicopter, you're an aircraft, so it's impossible. So that is something to bear in mind, all right, when you are reprogramming the vertical profile in the FMS of the Dash 8 Q400. So having said that, I hope everything makes sense, and until the next time, stay safe, enjoy your flying, and always be safe. Safety comes first, everything else is behind. All right, and until the next time, thank you very much, and be blessed.